2013, question 1 for AB. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G. So this is a rate, where T is measured in hours and the interval is 0 to 8. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. That's an initial condition. During these hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. This is the rate in, because the gravel arrives, and this is the rate out. It's a constant. So this is one of those classic rate in, rate out questions. Okay, part A, find G prime of 5. Using correct units, interpret your answer in the context of the problem. So G is already a rate. That gives the rate at which unprocessed gravel arrives, and that rate is now changing. That's what G prime would be then, is the rate of change of a rate. So this is the rate of change of a rate of change. So I would say okay. Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. When it says the total amount that arrives, you don't have to consider the amount that's going out. So you only think about the amount arriving. G is the rate at which gravel arrives, so a simple integral will get the job done. Part C, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. So now you do need to be thinking about the rates of change in and the rate out. So if the rate in is greater than the rate out, you'll know that the amount is increasing, and if the reverse is true, then the amount is decreasing. So that's the analysis we need. Since the rate of gravel arriving is less than the rate that's being processed, which is 100 tons per hour, then the amount is decreasing, the overall amount of gravel. Part D, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. So you need the overall rate of change of the amount of gravel. That means you're going to need to consider G and 100 together. So it helps sometimes to introduce a function, and it'll help keep you on task too. So here goes. Okay, so this is the overall rate. This is not the only way to do the problem, but this is the overall rate of change of the amount of gravel at any time. And if I take the integral of that change, I'll get the net change in the amount of gravel. And when I say the integral, I should say the integral of that rate. I'll get the net change in the amount of gravel. We start with 500 tons of gravel, so this is the most famous sentence in the class. And now I need to set a prime equal to 0. Another way that you could have done this is to set G equal to 100, which is really what I did to get this number. I found the intersection of the two. Let me just be really clear. You don't need to necessarily type G minus 100 into a calculator because I already had 100 and Y2. So if you just add 100 to both sides of the equation that I'm showing you right now, you'll get g of t equals 100. And that's how I found this time. And I stored it as a. Ooh, that maybe wasn't the best idea since I already called this a of t. Let's call that b then. Okay, we can see that the greatest amount occurs at time t equals b. Let me reread the question. It says, what is the maximum amount? And it doesn't say when does that happen. So I'm going to say thus the max amount is this.